Okay, welcome to section B, check for understanding. I'm probably just going to go through the first MCQ questions in this video and then the next question in the following video. This check for understanding also often for the higher order or the higher level of the question for these two topics. It's usually when you combine these two topics because you can see how they're very linked, right? Kinematics describes motion and dynamics explains in terms of forces why things move the way they do. So often these questions are combined, these ideas and these learning objectives are combined and tested in a single question like this, right? So the speed time graph shown, they tell you that the resultant force on the car is 0.6 newtons, so this is the resultant force. They're asking you to find mass. So just by looking at these two letters, which is a very good habit that I encourage you all to write, to mark the symbol of things that they're asking you to find or they give you, you should know that FRM definitely you're going to be using to find FR equals to MA to find the mass, right? So to find, they're asking for mass, so you're going to be FR over A. You have FR, but you're still you need acceleration. So how do you get acceleration from this graph? Speed time graph. In order to find the acceleration, it is the gradient, right? The rate of change of speed is the acceleration. How much the speed changes the acceleration. So how do you get acceleration? It is the gradient of this graph. So to find the gradient of this graph is the first step. So acceleration, you can get it from the gradient equals to the gradient of speed time graph. Okay, which is another concept tested in this MCQ question. Speed time graph. So to find the gradient, it is, you can take any 2 points. Let's just use the first and the last point. This is convenient because it's 0, so it's going to be easy to use. It's simply change in speed, so v minus u over t, or just the gradient. So I'm going to use this point and this point. 9, final minus initial, 0, change in speed over time taken, which is simply 3 seconds, so 3 minus 0, so answer is 3 meters per second square. I got my acceleration now as 3 meters per second square. FR is 0.60 over 3, will give me 0.20 kg. Alright, so the answer is B. Okay, question 17. Question 17, admittedly, is probably one of the tougher questions you would get. Okay, so a car of mass 1000 kg is slowly going down a steep hill. Sketch it. So it's going down a steep hill. Okay, the brakes fail and a driver uses horizontal sand field safety road to stop the car. Okay, so it's going to reach here and then this is like a lot of friction, right? The car enters the sand pit at a speed of 10 meters per second and is subjected to a stopping force of 2,500 newtons, right? So it's going to get 2,500 newtons. How far does the car travel before coming to a rest? So what is the distance is what they're asking you to find before it comes to a rest here. 0 meters per second. Okay, so how do you even approach a question like this? So you have final, so this is like initial speed, you have final speed, so this is like your v, you have u, you have fr, alright, and then you need to find distance. What are you going to do with all this information? So the first thing you can do is actually find the acceleration of the graph of this, because you also have m, right, which that's why you should put it in your diagram so you know all the things that you have, right? So it's 1000 kg. Let me write that in blue pen, which this is m. Okay, so we have fr and m. You know that, oh, I can probably find my acceleration. What am I going to do? What am I going to do with that? We'll see in a while. So with fr and m, let's just try to find our acceleration first, and we'll see where we go with that. So I'll do that here. Acceleration equals to FR over M. My FR is 2,500 newtons. Resultant force is 2,500 newtons. Mass is 1,000 kg. So this will give me 2.5 meters per second square. Now I have my acceleration. What's that going to do? Well, with my acceleration, I have U and V. What kind of formulas come to mind? What concepts comes to mind? A equals V minus U over T, right? So, let's see where that will bring us, okay? A equals to V minus U over T. So I can find my time with this, right? So this will give me V minus U. Okay, let me sub in the numbers first, probably less confusing. So my acceleration is 2.5. My V is final speed is 0 meters per second. Initial speed is 10 meters per second. How long will I take to slow down? That would be negative 10 over 2.5, which will give me negative 4. Oh, sorry. Sorry, my acceleration is negative, right? Because it's slowing down because my resultant force is negative. So it'll be negative, so it's negative over negative, which will give me 4 seconds. Okay, so not too bad. I have all this information now. Now I have additional information of time. What's that going to do for me? All right, what's that going to do for me? Well, if I want to find distance and I've got this couple of information, I know my acceleration is constant because my resultant force is constant in this question at least. What can I do? Well, this is the tricky part, which won't come intuitively to most of you. But what you can do is sketch a speed time graph. Because if you sketch a speed time graph, you will be able to find the distance traveled, right? So this is my speed time graph. What is my initial speed? My initial speed is 10 meters per second. What's my final speed? I know my final speed is going to be 0 meters per second. Right, so I'm going to start here, I'm going to end here. I know my acceleration is constant, so it's going to be constant down. Oops. I imagine there's a straight line. And then I know my time. How long does it take to go from 10 to 0? It's going to take me 4 seconds. So hey, what do you know? Now I can find my distance traveled because I know that the area under a speed time graph is... Okay, I should probably use S instead. So the area under speed time graph gives me the distance traveled, right? So distance traveled equals to area under speed time graph, which is a key concept that we already went through earlier. So this will be half times base times height, and that will give me 20 meters. So the stopping distance for a scenario like this is actually 20 meters. Answer is C. One skill I hope you picked up from me going through this video is just by writing the symbols down in a sketch or even in as you read, and then just kind of see what formulas might make sense. And if you're really not sure how to approach it, you can just do it step by step. Just try to find out quantities and see how they relate to each other. Okay, so for example, I see I had FR and M, maybe I can find acceleration. I have V, I have U, acceleration, maybe I can find time, and then how am I going to use all of this together? And the key skill here, of course, sometimes in a question like this, to find distance traveled, you can always sketch a speed time graph. Okay, so yeah, this is one of the more challenging type of questions like this. And I hope that, if it comes out, you'll be able to think of this revision question. Alright, see you in the next video.